Like when you normally think of like the boundary of like a manifold, you might think of it being on the exterior and surrounding like the interior components. But for the complex one sphere, it has the boundary at its very center, very peculiar. I should also mention that this complex one sphere, it allows you to embed a one-dimensional manifold in a 1D space time essentially. Because like the complex, like oftentimes when we think of like complex spaces, like we think of it as like, oh, it's a complex plane, and that sort of terminology makes it sound like it's like the complex plane is like 2D, but actually it's still only one-dimensional. Complex numbers can be a bit confusing and tricky. This has I think this might have a connection with what's known as Whitney's embedding theorem. It states that if you have an n manifold, you can always embed it in at least two real dimensions. And this means you can, like, let's say you have like a circle and it's like a one-dimensional manifold, and let's say you were confined to like real dimensions. If you wanted to embed it, you'd have to embed it on a plane. And if you had like a sphere, two sphere, then you'd have to embed it into 3D spacetime as like the surface of like a 3-ball essentially. Whitney's embedding theorem says that if you have an n manifold, you can embed it in like two n real dimensions where it's not going to intersect with itself.